Hello students, today I am discussing the energy profile diagram and stereochemistry of SN1 reaction. Okay, so let us see the energy profile diagram first. In energy profile diagram, we will see the energy variation during the reaction. So here we are taking the x-axis, on the x-axis we are taking the progress of reaction, on the y-axis we are taking the potential energy of the particular reactants. So you can see two main curves. The two main curves indicates the two transition states of SN1 reaction. So first transition state is nothing but formation of carbocation, and second transition state is nothing but attack of nucleophile on the carbocation. Okay, now let us see this. I am taking reactant in the beginning, that is tertiary butyl bromide along with nucleophile. Okay, so this tertiary butyl bromide is forming carbocation. Okay, this is a slow step of the reaction and it requires this much activation energy, hence we'll say this as a carbocation formation. And in second step you can see clearly this carbocation is getting attacked with nucleophile and it is liberating, here I wrote the breaking of Br minus and the carbocation formation. This carbocation is attacked with nucleophile which is having very less activation energy. You can see the less activation energy in the product, this product formation. So you can see clearly. So it is forming a product called tertiary butyl alcohol along with leaving Br minus outside. So it is requiring less activation energy. As this carbocation is unstable, this reaction is exothermic. That means it liberates our energy outside and forming the product. But here you can see clearly this is requiring more energy in order to form this carbocation. It is requiring more energy and we are saying this as endothermic reaction. That means first step requires more energy to form the intermediate, that is carbocation. And second step, this intermediate loses energy outside while forming the product. Hence we'll say that as exothermic reaction. Okay, this is about energy profile diagram. Let us see the stereochemistry. The stereochemistry indicates arrangement of the particular groups around the carbon. So in order to explain the stereochemistry of SN1 reaction, we are taking the 2-bromobutane, that is a chiral molecule. So chiral carbon means what I told you already. Chiral means the carbon which is having different groups around the around itself. So you can see here this is a carbon. This carbon is having different groups. One is C2H5, another one is Br, and one is H, and one is CH3. So different groups are present. So it is easy to explain stereochemistry when we are taking the chiral carbon or chiral molecule. So you can see beginning this 2-bromobutane is attacked with ethanol. Ethanol consists of OH. So this Br is replacing with OH here. Here two products you can clearly observe. One is inverted product, another one is retention product. Retention means the group exactly attacks on this Br position. Br is leaving outside and OH is attacking on this position. Okay, you can see clearly same position is okay. And next, inversion means opposite direction, opposite position to this Br. Okay, two main products are possible in this reaction. One is inversion, another one is retention product. We call this process as partial racemization. Okay, racemic mixture of inverted and retention product is forming. Hence, we call this as a partial racemization. And now we'll see why we are getting the partial racemization. So we are seeing the carbocation structure, the carbon which is having three groups around itself. You can see here. So three groups means it is a trigonal planar in structure. sp2 hybridization and we are having a trigonal planar structure. So whenever we are getting the formation of carbocation, along with this there is a Br minus attachment. So it is leaving outside but still it exists as a pair. Carbocation halide ion pair is forming. So when we are adding the nucleophile attacks from the back side and front side also. Okay, so the front side here nucleophile already Br minus is present. No, this Br minus opposes, it hinders this process. Okay, but back side it is free and it attacks freely and forming the inverted product. So you are getting inverted product 83%. You can see more concentration of inverted product is forming. But you can see retention product is less because of the Br minus hindrance. We are getting less amount of retention product. So here inversion dominates a retention process. Okay, so that is mainly about partial racemization, and this is the stereochemistry of SN1 reaction.